All right, today's topic is using ratio tables. So we are supposed to find the missing values in the ratio table, which is pictured below, and then write the equivalent ratios down here. So these are nothing but fractions. So I treat all ratios as fractions. So we are comparing basically the number of hours it takes to travel a particular number of miles. So I like to write them out all as fractions. So the first one I see is we're comparing miles to hours. So you could write it like this: miles to hours. But miles to hours is simply, then the very first one we're given is 4 to 3. And then it's supposed to be equal. How do I know it's supposed to be equal? Is because the word equivalent means basically the same value of fractions or ratios, only they're just different numbers. So then we have it's supposed to be equal to this box over here, otherwise known as an empty number. So I'm just going to leave that as, we'll call that x for the unknown value over 6. Now, there are multiple ways to do this, but I like to spot patterns. So the very first pattern I noticed is that 3 times 2 gives me 6, and what you do to the bottom, you have to do to the top. You should have learned that in elementary school. So we are now going to multiply the numerator. 4 times 2, which gives me 8. So x is 8. So you should realize that everything is doubling, right? So from 3 to 6, it's doubled. From 4 to 8, it's doubled. Now let's look at this set of ratios. Now that we have those, that would be 8 over 6 is supposed to be equal to 24 over the unknown. And this time, the unknown that I'm going to use a better variable. That variable there has to stand for hours. So I'm going to use the letter H for hours. Now looking at this problem here, how do you go from 8 to 24? I see it has been tripled, otherwise known as multiplied by 3. And if you're multiplying the numerators by 3 to make equivalent ratios or equivalent fractions, you have to multiply the denominator by 3. So what is 6 times 3? 6 times 3 is 18. So that means we've just found that it is 18 hours for 24 miles. On into the last one. I'm going to have to move on down here, but now I'm going to focus on these 4 boxes. And again, I'm writing them as fractions, right? Because ratios are nothing but comparing two numbers, and I write them in fraction form. So it's 24 over 18 is supposed to be equivalent to 96 over the unknown amount of hours. So trying to spot patterns here, this one's a little bit more difficult. Let's go ahead and pull up the calculator. I wonder if 24 goes into 96 evenly. I think it does, and we can do this by doing the inverse operation of 96 divided by 24. It's 4. So what that means is it is 24 times 4 gives me 96. And what you do to the bottom, you have to do to the top. So this means we're also going to do 18 times 4. And 18 times 4, just use the calculator here, 18 times 4 is 72. So we have just figured out that the number of hours is 72, and that's what goes in this box right here. And then a way we can check all these to make sure they're correct is you grab the calculator, and we're always going to be doing numerator divided by denominator, otherwise miles divided by hours. So I'm going to do 4 divided by 3. And that gives me a value of 1.3 repeating. Guess what? Now I'm going to do 8 divided by 6. 8 divided by 6, and it better equal 1.3 repeated. And it does. On into the next set here. Now I'm looking at 24 over 18. I'm going to do 24 divided by 18, and it better equal 1.3 repeated, and it does. And the last one is 96 divided by 72. All those values are exactly the same. So now all I have to do is fill out the boxes. So it says 4 to 3. We had that one. And then it was blank to 6. Well, blank to 6 was 8. And then it was 24 to blank. Well, 24 to 18. And the last one was 96 to 72. All right, so that was finding missing values in a ratio table where we're finding equivalent ratios, otherwise known as equivalent fractions. On into the next one. Finding the missing values in the ratio table again. then write the equivalent ratios. The same thing. So we are comparing students to teachers. So that is the ratio. We are comparing students to teachers. And I have already spotted a pretty neat pattern. If I take 24 to 2, that's our very first ratio we were given, and I simplify this, and you simplify fractions by dividing the numerator and denominator by a common factor. Well, I notice they're both even, which means they're both divisible by 2. So this will kick out 24 divided by 2 is 12, and 2 divided by 2 is 1. This ratio is in simplest form, and this means for every one teacher, there's going to be 12 students. Why is that? Because that's just the way the classroom is set up. So that means you take the number of teachers and you multiply it by 12, and it will give you the number of students. So again, going from teachers to students, we always multiply by 12. So to go from 2 to 24, you should realize that's a multiplication of 12. So we can actually do that with the number 4 here. If we have 4 teachers, how do we figure out the number of students? Well, it's a times 12 ratio. So 4 times 12 is 48. Now we have empty boxes on the bottom. So we're going to be doing the opposite, otherwise known as the inverse. Well, if you go from teachers to students, so teachers have to be multiplied by 12 to end up equaling the number of students. What happens if we go backwards or reverse the process? What if we have a number of students? How do we get to the number of teachers? Well, the opposite is just known for the inverse. Well, the inverse of multiplying is dividing. So now we're going to be dividing by 12. So again, I'm going to go from the 12 number of students over to how many teachers? Well, I'm going to do divide by 12. 12 divided by 12 is 1. And the last one here, the number 36, we're going to take that, and we're going to divide that by 12. And 36 divided by 12 is 3. Now all you have to do is fill out our empty boxes down below. I'll highlight those 3 spaces, and we're just going to use our table to help us. So the table reads, let's see, 24 to 2, that was the first one, and then it's 12 to 1, so 1 goes in the first box, and then it's blank to 4. Well, we already figured it out, it was 48, and the last one is 36 to blank. Well, it's 36 to 3. All right, on into the last problem. It says the nutrition label shows there are 75 milligrams of sodium in every 12 crackers that you consume. Well, how many crackers do you consume? You end up eating 21 crackers. We want to know how much sodium do you end up consuming based on the number of crackers? Well, we ate 21 crackers. Well, this is nothing but equivalent fractions, otherwise known as ratios. So the ratio is 75 milligrams of sodium, so 75, and that stands for milligrams of sodium over 12 crackers. Now we have to set that equal to the other ratio we have to figure out, which is you eat 21 crackers. The 21 crackers has to go in the denominator position because it has to do with crackers. Now up here is how many milligrams of sodium. I don't know how many milligrams, so I'm going to use M for milligrams. Okay, so this one is a little bit harder to figure out, but I'm going to teach this using cross multiplying. We are going to cross multiply, which will end up giving us an equation. So pay close attention to how this works. It is 12 times M, which is 12M, but then you have to multiply diagonally the other way, and 21 times 75, 21 times 75, 1,575. Now these values are supposed to be equal, and the only way to figure out what M has to be is to solve this equation. This is called an equation, and we have to solve for our variable, and our variable is M for milligrams. So how do we do this? Well, I like to draw a line down the equal sign because this is nothing other than like a teeter-totter or a seesaw or a scale. The left side has to be equal with the right side. So 12 times the unknown amount of milligrams has to equal 1,575. Well, we can solve this by doing the inverse. We have 12 m's. Well, how do you get down to just 1 m? You would end up dividing it by 12. The reason why this works is 12 over 12 is equal to 1. So the moment we divide it by 12, we end up getting 1 m. Well, 1 m is just written as 1 m, just m. But what you do to the left side, you have to do to the right side. So now we have to divide the right side by 12. So we'll use our handy calculator. 1,575 divided by 12, which gives us 131.25, or read correctly, 131 and 25 hundredths. If we think this is correct, what we're saying is that number is the number of milligrams that you would end up consuming, milligrams of sodium, based on eating 21 crackers. And the only way we can truly check this is to see if these two values end up being the same, otherwise known as equivalent. So how am I going to do that? I'm going to use my calculator. Here's what I'm going to do. I'm going to do 75 divided by 12, because remember this line right here means to divide. So 75 divided by 12 gives me 6 1/4, or 6 and 25 hundredths. Now the same thing should be true on the right side, or the other ratio of 131 and 25 hundredths divided by 21 better equal 6.25. And it does, which means we are correct.